Good day to all the participants, and today we are going to discuss about the draft system and fans which are available in boiler. At the same time, we will try to focus on how this draft system helps in maintaining the burning of fuel within the boiler as well as evacuation of product of combustion, gaseous part, and how this is actually impacting in heat transfer within the furnace as well as in heat traps. We define draft as a differential pressure between a system and the surrounding, and this differential pressure determines the mass flow from system to the surrounding or surrounding to the system depending upon the differential pressure. In the boiler, we require to supply combustion air, and this combustion air comes in different forms, either primary or secondary air, to supply oxygen for the combustion, and as a result of combustion there is we get the product of combustion, and out of this product of combustion ashes are collected in various phases, either in the bottom of the furnace or in different heat trapping zones or outside the furnace and boiler. We have dust separating system and collection system, and the cleaned flue gas is disposed through the chimney and evacuated by induced draft fan. In general, inside the boiler we have 4 different categories of draft generation. First kind is natural draft, that is created naturally with the help of the system of introduction of chimney, and artificially we create draft within the boiler system, that is supported by forced draft fan, induced draft fan, and a combination of these two is referred as balanced draft system. In natural draft system, we introduce air within the combustion zone of the furnace without the help of any fans or external equipments, and this air, when it is participating in the combustion and as a result of that flue gas is generated, this flue gas is passed through a stack or chimney, and while passing through the chimney we observe that this stack of flue gas is having a density which is less than the air density. So naturally, outside air density and internal flue gas density, there is a density difference. Due to this density difference, the air is coming inside the boiler naturally and flue gas is exiting the stack naturally. So that's why it is called natural draft. In forced draft system, we take the help of a fan which is called forced draft fan. As we run the fan, it is forcing air within the boiler furnace, which is coming within the furnace through a box of wind, which is also called wind box, after passing through air preheater, and due to this effect, so there is a positive pressure within the furnace, and along with natural draft, this positive pressure within the furnace of air, that is helping in flow of air within the furnace and exhausting the flue gas out of the chimney. So that's why it is named as forced draft system. In larger capacity boilers, where flue gas passage is long enough and there is a number of passes, so naturally system resistances are more, and we need to incorporate some evacuating device so that there is smooth flow of product of combustion across the furnace and after the furnace in the heat trapping zones, and we can evacuate the flue gas smoothly through the from the system and through the chimney. So naturally induced draft fans are installed at the exit passage of the flue gas and just before the chimney, which can force the evacuation of the flue gas from system to the surrounding through the chimney. Almost all the modern power generation boilers and high capacity utility units are having both forced draft fans and induced draft fans, and the combination of these two are creating a balance in the draft pattern within the boiler system. This balance is essential depending upon the requirement of draft at the inlet condition, which is maximum positive, and at the outlet condition where it has to be maximum negative. So as a result, the entire velocity of combustion process, product of combustion are balanced. So the combination of FD and ID system creates the balanced draft system. Now let us try to understand the fans. By definition, fan is a volumetric rotary machine to deliver gaseous fluids at a rated quantity at a given inlet pressure and temperature condition, and it consists of bladed impeller, and there may be encasing outside the impeller, or it may be open type also without any casing. But anyway, in both the cases the purpose is remaining same. It is to deliver gaseous fluid at a rated quantity, and that is determined by the temperature and pressure. Fan is not the only volumetric machines used for transfer of gaseous fluids. We have other equipments like blower and compressor. They are also very much used in power station. For fan or blower or compressor, what makes them different is related to a term which is called pressure ratio. It is actually a ratio of outlet pressure and inlet pressure of the fluid on which gaseous fluid they are transferring. And naturally for fan, pressure ratio is less than 1.2, and for blower it is within 1.2 to 1.4, and for compressor actually pressure ratio is more than 1.4. And beside that, while fan is a volumetric machine, the key aspect is quantity delivered by the fan. It is a device, quantitative device. That means how much quantity we are delivering. But for compressor, pressure is important aspect. The quantity is not the issue, but the pressure head generated by the compressor, that is important aspect. Let us now try to understand the governing principles of fan performance and basic fan laws. So when diameter of the impeller is constant, then flow quantity is proportional to RPM at which the fan is run, and differential pressure that is existing between the inlet and outlet, that is proportional to RPM square. That means differential pressure developed across the fan, and power consumption to run the fan or horsepower, that is proportional to RPM cube. Again, when the pressure, RPM is constant, then we find the flow is proportional to d cube with respect to diameter of the impeller, and as we see, this differential pressure across the fan proportional to d square, that is diameter of the impeller square, and power requirement to run the fan is proportional to d to the power 5. So these are the basic fan laws. When we install a fan, first of all we have to see what is the purpose of utilization of the fan, whether it is for supplying air or some other gases like flue gas evacuation, or it is for supply of gaseous fuel also. So naturally the parameters we have to review for size selection of the fan, it is volume or mass flow rate, pressure requirement at the pressure demand at the fan inlet, and the pressure at the fan outlet, temperature of the gaseous fluid, density of the medium, and how much is the dust concentration within the gaseous fluid. So all this has to be taken care of for sizing. Let us try to understand now the schematic layout of the entire system of air and flue gas circuit, and how these different fans are placed for a large capacity utility boilers. Now if you see, for big units we have a number of fans. In case of primary air supply system, we have PA fans, 2 numbers of PA fans, and PA fans are placed in the 2 passages actually in terms of layout of the system. So say PFN A and BFN B, these are supplying primary air. They are flowing, collecting air from atmosphere, and they are sending it to the air preheater and primary air preheater part, and after getting heated, this hot PA is sent to the milling system, and there is arrangement to supply cold primary air also for your tempering the total hot air flow in the primary air system. And this PA is going to the mill, primary air going to the mill, and then it is drying the coal, flying the coal to the furnace. And there are FD fans. FD fans are also collecting air from the atmosphere, sending it through air preheaters, secondary air preheater path, and then they are going through wind box and entering the furnace, and there is secondary air dampers. They are regulating the secondary air flow, or in case of front firing, opposite firing, or side firing arrangement, we have air registers. But whatever may be, the secondary air is going inside the furnace. So primary air is carrying the coal or solid fuel, and secondary air is supplying the air required for complete combustion. So there is these 2 types of fans. Beside that, for igniting the secondary fuel like oil, we have igniter fans. Igniter fans are providing the initial air requirement for igniting the oil within the furnace, because in that case, if we supply the full air, it will cool the furnace, and the flame cannot sustain. So naturally igniter air fans are provided to supply ignition uh, oxygen with the secondary fuel like oil. Now after the combustion, whatever product is there, it is passing through various heat traps, like heat is absorbed in furnace water walls within the evaporator chamber, then primary and secondary superheaters, then reheaters, then economizers, then air preheaters, and after that it is passed through the your ESP and mechanical dust collectors, and then it is evacuated by ID fan and disposed through chimney. So naturally we have PA fan, FD fan, igniter fan, ID fan. These fans are there. Beside that, for flame scanning, we have flame scanners within the boiler furnace, within the vicinity of the boiler furnace. These flame scanners are scanning the flames within the furnace continuously, and remotely the presence of flame is observed from the control room. But these flame scanners cannot work beyond a temperature of 90 degrees centigrade, so naturally they need cooling air continuously. So scanner air fans are provided to maintain the cooling of flame scanners, and for that scanner air fans are there. There are also AC and DC scanner air fans. So this way we have different fans, and some of the locations we have booster fans before ID fans to boost up the evacuation of flue gas, and some places we may find that gas recirculation fans. These gas recirculation fans recirculate the flue gas partially within the furnace, and this arrangement is basically a part of superheater temperature control to minimize the availability of excess air and to dilute the total product of combustion, so that heat available for absorption is reduced. So this way we are having different fans. So in the primary air supply system we have in general two primary air fans, or each primary air fan is supplying to a group of mills, and there is a arrangement of discharge bifurcated into two parts, and one part is passing through air preheater, primary air heating component, and another part is bypassing the air preheater, creating a cold air duct, cold primary air duct, and the hot primary air and cold primary air are mixed together before it is sent to each pulverizer. By this way we actually control and regulate the primary air temperature getting inside the pulverizer. And beside that there is some seal air provision in the pulverizer. Sealing is essential, otherwise as the milling system is mostly pressurized system, in some of the plants we have also exhauster based suction milling system, but generally most of the plants are having pressurized milling system. In that system the entire mill is under pressure. So naturally if coal is being ground and it is supplied with primary air to fly pneumatically convey the coal to the furnace, so there are every chance that coal dust which is generated within the mill that may ingress into the vertical shaft or within the gearbox through which prime mover is running the mill. So to prevent the ingress of coal dust which can contaminate the lubricating oil or gearbox oil, so we have a constant supply of sealing air. This sealing air supply is either done by a seal air fan or we sometimes use when seal air fan is not available, a connection from primary air supply system, cold primary air supply system, and that is providing the sealing air for the purpose. So this way a primary air system is placed. In general, there are two types of systems. One is a cold PA system and hot PA system. In case of cold PA system, PA fan is drawing cold air from the atmosphere, and after passing through air preheater, part of the primary air is getting heated and some part is bypass the air preheater, and that is mixed with the hot primary air, and then that is going to the milling system. So naturally we find this is the cold PA system where PA fan is drawing cold air from the atmosphere. But many smaller unit where PA fan is not drawing the cold air, it is a hot PA system, and in hot PA system FD fan is supplying the primary air as part of the total air. So in that system FD fan is drawing the air, part of the FD air is passed through air preheater for heating, and then it is distributed into secondary and primary. Primary air is sucked by primary air fan and secondary air is going to the wind box. So in this system, as primary air is supplied by FD fan, after air preheater, so this system we are getting hot primary air, and for tempering purpose some part of the FD fan air is bypassing the air preheater, and that part is added to the hot primary air. So this system is called hot PA system. But in bigger capacity units, larger units, we have FD fan and PA fan both are drawing air from the atmosphere, and FD fan is supplying only the secondary air. That means FD fan is drawing air from the atmosphere, and after drawal this air is passed through air preheater. In case of that type of preheating arrangement, FD fan air is passing through secondary air preheating part, and then this hot secondary air is moved to wind box, and from the wind box it is entering and controlled through the secondary air dampers entering into the furnace. So this way we have secondary air supply system, and it is around 70% of the total air requirement of the firing arrangement, and primary air accounts for 30% of the total air requirement. The induced draft system in the boiler is dependent on induced draft fan. In general, there are two induced draft fan we find in large capacity units like 500 megawatt, 250 megawatt, 220 megawatt. So these units where two ID fans are there, they are drawing flue gas from the ESP and disposing it to the chimney, and they are actually this ID fan they are having more volumetric capacity compared to FD fan, because they are handling hot flue gas, and all FD and PA fans are handling atmospheric condition air. So naturally ID fan capacities are more than the FD or PA fan. They are the largest capacity fans in the boiler, and they are running at very slower speed so that their vibration problem can be minimized, and they are having the housing, inlet guide fans or dampers, and impeller with bearing support, shaft seals, and most of the fans, ID fans, were supplied with hydraulic coupling so that we can control the RPM of the fan, and we can regulate the induced draft and how much quantity has to be evacuated. Some of the locations we also find variable frequency drive for bigger capacity units. VFD type speed control mechanism is also there. However, the ID fans actually they are drawing the flue gas. Naturally, they are maintaining the entire draft within the flow within the furnace as well as at the back end of the boiler. So naturally, flue gas velocity is dependent on ID fan created draft, and as you know, this flue gas velocity determines how much heat will be absorbed in various heat traps. So ID fan as such is helping the amount of heat transfer and its distribution across the various heat traps. That is very important part, and ID fan draft control is actually dependent on we have furnace draft measuring device on that. So furnace draft regulate ID fan draft creation and how much RPM will be there in the ID fan to create the induced draft. As already mentioned, there are some other fans also in the boiler system, like igniter air fan, which provide initial combustion air to the igniters actually through a separate wind box, so that there is no cooling within the furnace with the main secondary air supply, and only sufficient air is available for igniting the secondary fuel like oil or gas. Then we have scanner air fans. Scanner air fans are installed to cool the flame scanners, which cannot actually operate at a temperature beyond 90 degrees centigrade. They are open to radiation heat within the furnace. So naturally we need continuous cooling of these flame scanners through scanner air fans. We have both AC and DC scanner air fans. Next is the mill seal air fan. Mill seal air fan is supplying sealing air to the milling system, gearboxes at the joint of the vertical shaft, so that there is no ingress of coal dust or primary air in the mill bearings or gearboxes, which can contaminate the lubricating oil or damage the bearings. Beside that, we have already we have discussed about the gas recirculation fan and about the booster fans, and there are some places we are also having some other exhaust fans to evacuate the create vacuum. So this type of fans are there at various locations, which are supporting the different systems, and they are all work together depending on the requirement. Mill seal air fan line is actually intake is taken from primary air system, cold PA system, so that in case of failure of seal air fan, sealing air can be supplied through the PA cold PA intake line. We can classify the fans according to direction of flow into two categories. One is called radial, another is called axial. In radial fan, suction is axial and discharge is radial. That's why it is called radial fan. And in case of axial fan, suction is across the axis and discharge is also along the axis. That's why it is called axial fan. So, as shown in this slide, in case of radial fan, the medium enters the impeller axially and pass through the impeller radially. That's why it is called as radial fan. Radial fans may be three types: forward curve blading, backward curve blading, and radial blading or straight blading. And these are the best. This classification is based on how they are curved in terms of the tangent drawn at the tip of the blades, impeller blades, whether it is making an acute angle with the direction of flow, or whether it is making an obtuse angle with the direction of flow, or whether it is making 90 degree with the direction of flow. It means that in case of forward curved blading, the blades are inclined towards the direction of flow, and in case of backward curved blading, the blades are inclined towards the backside of the direction of flow, and in case of straight or radial blading, they are perpendicular to the direction of flow. So forward curved blades are suitable for either for primary air fans or ID fans, and in case of FD fans or ID fans, we use backward curved blading. Radial blades blading is mostly found in exhausters, where we try to minimize the erosion. Exhauster fans are used for suction type milling system, which are actually handling coal air mixture, and they are sucking the coal air mixture from the milling system and pulverizer and sending to the coal carrier pipe to the furnace through the burners. So these are the types of blading arrangement in radial fans, and they are suitably utilized according to the requirement. The axial flow fans or axial fans can be classified into two categories: impulse type or reaction type. The classification is based on a term that is called degree of reaction. By degree of reaction, it is the amount of head developed by the impeller with respect to the amount of head available across the fan. That means how this turbo machine or this volumetric machine is generating flow over and above the system resistance, that is determined by degree of reaction. If degree of reaction is below 0.8, it is called reaction type axial fan, and if it is more than 0.8, it is called impulse type axial fan. Impulse type axial fans, they are, if you see the constructional features, they are having a hollow shaft. On this shaft, actually, we have at the end coupling arrangement to couple with the motor, and this fan is having key fitted impeller holding arrangement. It is having a critical speed above operating speed, mostly we take care that way, and this is simply supported in anti-friction bearings, and lubrication is generally done by grease. There are inlet guide vanes to take in the gaseous fluid inside the fan, and we have discharge dampers also. Speed of the fan is generally at fixed condition in case of FD fan application and PA fan application, and flow is controlled by discharge and IGV, discharge dampers and IGV. It can it can be placed in such a way that space requirement is less, and the blades are of constant thickness. Unlike impulse type axial fan, reaction type fans are much more stronger, and they are more efficient, and they are more efficient in the sense of part load operation, and we have blade pitching arrangement and hydraulic servo motor to control that blade tilting, and due to this blade tilting arrangement, the quantity of gaseous fluid flow within the fan is getting controlled. So beside inlet guide vane and discharge damper, this type of reaction fan can regulate the quantity of gaseous fluid flow across the fan. By that they can control the degree of reaction and discharge through the fan. They are also simply supported based on anti-friction bearing, or some of the cases there may be journal bearings if the speed is high. There may be double staging or single staging of blade. It depends upon the configuration. So we find that based on exit tip angle, the radial fans may be classified into backward curved, radial bladed, or forward curved. Backward curved blade may be curved radial fans blading may be constant thickness or plate bladed, or aerofoil structured blading may be there. So depending upon the requirement, those are chosen. The BHL fans, which are based on Polish design, KKK design fans, depending upon bearing support and flow arrangement, these radial fans can be classified into single suction overhang, single suction simply supported, or double suction simply supported. Single suction overhang, they are designated as NDFV, HPSF, or NDM. Single suction simply supported, they are called NDV, and double suction simply supported, they are called NDZV. These are the standard nomenclature of BHL fans. Let us focus now on fan designation. For radial fan, we have already seen there are different designation depending on fan bearing arrangement and flow patterns. So here in NDV fans, NDV implies radial single suction simply supported impeller, and next to NDV you will find the two digits which actually represent impeller tip diameter in decimeter, and followed by a letter that designates the impeller type. And this type of fan, these radial fans, if it is radial double suction type, simply supported impeller, then it is called NDZV, and similarly tip diameters may be there. And if they are having cantilever type of arrangement, overhang impeller and radial single suction, then it is called NDFV. So this way we find the nomenclatures for radial fans. And if we see the radial fan impellers, they are actually having the impeller eye and shroud rings actually, and there may be a center plate, and blades are fixed in such a way that they are welded completely with the center plate or suction shroud rings. And there is a shaft, impeller shaft. This shaft is actually fixed with the impeller rotor in the half position, and they are either riveted or welded. Mostly they are found in riveting type of bolting arrangement, and they are covered with the arrangement is covered in such a way there is no erosion effect of loosening, and shaft is fitted with the rotor through some key arrangement. Key slot is there, so that way they are connected. And in case of ID fans, if you see that shroud rings are arranged in such a way they can fit with the suction eye of the casing. Involute type of casings are used for centrifugal fans, and this involute casing that gives the flow pattern from suction, axial suction to radial discharge, and gradually there is a control mechanism also. We have inlet guide vane based control as well as discharge dampers. For overhang impellers like PA fans, we find the bearings are placed in one side only. Both the bearings are placed in one side, and as it is overhang, suction is taking place axially in the non-bearing end, and radial discharge is taking place across the fan boundary. And this type of arrangement is available in PA fan applications or some booster fan applications. So that way they are made. For ID fan, the arrangement is double suction type mostly, and radial fans. As there is double inlet and radial discharge, so you will find that inlet guide vanes are placed at the both side suctions, and not inlet guide vane, there are suction dampers, and discharge side also we are having dampers, and these dampers are placed in such a way that there is no Coriolis forces or flow separation that can occur. And bearings also, if you see the bearings are made, particularly the fans which are handling high temperature flue gases or high temperature gases. In that case, these are cantilever supported, not cantilever, it is simply supported. So for this simply supported arrangement, there is one bearing is towards the motor and another is away from the motor. The bearing which is towards the motor, it is shaft is connected by a coupling to the motor coupling, or there may be hydraulic coupling, whatever may be. So there is a sleeve, so it is a fixed bearing. The bearing towards the motor is a fixed bearing, and as the fan is handling hot gases, so there is some expansion. So there is a free end bearing. So the bearing which is away from the motor, it can accommodate the expansion of the shaft, and that's why non-driving end motors, bearings are always free to move. Shaft is free to move through this non-driving end bearing. So this is also called non-located bearing. So motor side bearing is called located bearing, and it is fixed in the position. Axial fans are designated like AN fan or AP fan. A represents the axial fan, N represents non-profiled blading, that means thickness is constant. Next is small m or some other dimension letter I, which represent nominal tip diameter of the impeller in decimeter. This will be in digit. And E6 is the diffuser designation. You know, axial fans are having diffusers to prevent flow within control of below sonic range. And profile bladed fans, AP fans are actually used for FD fans also. These fans, A represents axial fan P represent profile blading, that means this structure may be aerofoil or something like that. Next digit represent number of stages, AP1 or AP2. This represent whether two stage of blading is there or single stage of blading is there. Then tip diameter is given in digit. Then you get half diameter in decimeter. So this way designation of axial fans are done. For supporting arrangement of these fans, we have sleeve type Dodge Palmer block bearing, which are journal bearings. They are supplied with oil ring based lubrication arrangement, and sometimes these bearings are preferable at speed around 1000 and above, 1000 to 3000 rpm, and when speed is less, there we have double row roller journal roller bearings, and this kind of arrangement we have rolling contact anti-friction bearings, and they are grease lubricated. And in case of oil ring lubricated bearings, the lubrication may be through an assisted lubrication arrangement with pumps, or there may be supply of oil by ring lubrication. Anyway, most of the system nowadays we have oil pumps and continuous supply of lubricating oil, and there are pumping stations or lube oil pumping stations fitted with strainers and coolers, so that lubricating oil can be continuously charged, recirculated back, cleaned and cooled, and again supplied to the bearings, journal bearings. So this way we arrange the bearings and their lubrication. So for radial fans, there are following parts. As you see, we have suction side inlet guide vane. We have a spiral involute casing to accommodate the impeller. We have impeller. In case of radial fans, this impeller is having arrangement with a shaft. That shaft is supported through the bearing. It may be simply supported from the both ends, or maybe cantilever type of arrangement, one end double bearing support. So this way radial fans are arranged. And when we see the axial fans, in case of axial fans, only thing is that the suction is taken along the axis and discharge is also axial. So naturally there is diffuser, there is impeller fitted with a shaft. This shaft may be hollow, and impellers may be more than one stage impellers may be there, depending upon the type of reaction fan, AP1 or AP2. Then we have coupling for fitting with the motor, and there is inlet dampers and discharge dampers. So this way these axial fans are arranged. Unlike radial fans, in axial fans, particularly in AP fans, we have axial bed pitch control. When we talk about blade pitch control, this is the arrangement which uh, ensure that we can control the flow of fluid, gaseous fluid, within the fan impeller itself. In case of radial fans, impellers are fixed, but these AP-type fans, these impellers can be tilted with the axial blade pitch control arrangement. We can tilt them up to 60 degree in 16 divisions, and that way we can control the quantity of gaseous fluid flow across the fan. So this is an additional feature along with damper control, inlet dampers and outlet dampers. So this kind of fans, they are specially accommodated within the diffuser, a hydraulic servo motor fitted with oil supply arrangement, control oil supply arrangement, and with this control oil supply they can tilt the individual blades in unison, which are coupled together, and that way we can control the regulate the gaseous fluid flow. Beside that, this kind of fans, we have a diffuser, and this diffuser core actually covers the outlet duct and make the flow stratified, and there is no eddy formation and sonic effect, I mean flow going beyond Mach number due to this diffuser's presence. So this way we are controlling the flow through the AP fans, and these AP fans, if you see the servo motor actions, servo motors are providing the control oil, and whenever there is a requirement of total opening, this control oil is drained and naturally opening turns into the original position of complete opening. So this way we regulate it, and their blades are connected with the arrangement so that we can have a rack and pinion arrangement. With that, when they are rotating all rotating together, and pitches are controlled at this same level. That means if one is rotating by 3 degree, all the remaining blades are also rotating at 3 degrees this way. So this is the mechanism of axial blade pitch control, and you see these blades are placed in such a way that they are totally fitted in the hub and can tilt with respect to impeller hub without getting any leakage of control oil or without affecting the flow beyond the limits. So this is the mechanism, and we have also some shaft protecting device. We have a tube covering at the inlet ducting of the suction, so that if there is a flow of dust-laden gas, the shaft is not getting damaged. There are stiffeners to withstand the casing, because there is a change in direction in the axial flow fans. Suction is axial and discharge is also axial. So naturally There is some directional vents also, and horizontal splitting arrangement is there to prevent eddy formation in the flow passage. Inlet guide vanes are also arranged similar to the blade pitch control type of arrangement. There is turnbuckle arrangement. This turnbuckle arrangement is fitted with loading cylinders, pneumatic loading cylinders. From the remote position, these pneumatic loading cylinders can be operated, and with this operation, turnbuckles tilts the inlet guide vanes together in the same range. And in fact, whether we operate the inlet guide vanes or inlet dampers, the flow restriction is from 30% to 70%. Beyond 70%, the flow is 100%. That means when opening of dampers are by 70%, there is flow is 100%, and when we go for complete closing of the dampers, even then there is minimum 25 to 30% flow. So control is basically within a range of 30 to 70%. We don't have beyond that. Now in this side, as we have seen shown, the direction of rotation, whether it is clockwise or anti-clockwise, that is always designated from the motor end. So in axial fans, from the motor end, we try to designate the direction of rotation of impeller of the fans, and that designate it. In this next slide, we see how an axial fan is used as FD fan in a power station, and this type of fans, suction side is provided with a noise attenuator so that we don't have any noise due to suction, and noise is dumped. Now in case of inlet guide vane, another factor is there. Now these guide vanes are actually giving a swirling effect to the incoming fluid, gaseous fluid, and due to this swirling effect, whenever the gas enters within the passage of the impeller, they are getting radially discharged more quickly, and effectively the centrifugal force is utilized. So inlet guide vanes basically more better arrangement compared to suction dampers in suction ducts, and they are better arrangement in terms of controlling within the regime, as I told, from 25 to 70% of the opening, when we get 100% to 30% control over the total flow. So that is all about your fan constructional features and how these fans are used at different location according to their types, and how they are controlled, regulated depending upon the requirements. Thank you all. This is all about draft system, their importance in boiler air and flue gas passage, and how they are incorporated for better management of boiler performance, and different fans which are used for the purpose of air supply and flue gas evacuation. If you have any doubt, please email me. We will definitely answer your queries. Out of the context also, you can ask me relevant to the taught subject.